Hi, my name is William Turley. I'm the Executive Director of the Construction and Demolition Recycling Association, a nonprofit organization that promotes the recycling of C&D materials in North America. I also run the industry's magazine. How much C&D is out there? It's a question I get asked a lot. The original 1997 estimate of 136 million tons was always low because it was only building-related C&D. There are two types of C&D to be considered. Obviously, the famous one is more famous one is building related, but let's not forget the millions upon millions of tons generated by road and bridge work. 2004 EPA estimated their building related one up to 170 million tons, but they just didn't know how to do a good estimate on road and bridge, so they left it out. We estimate there's at least 350 million tons generated annually, but I have seen estimates of 650 million tons annually. I mean, think about all the road work and everything that goes on, all those tons there. It has to be a lot. So how much of it is recycled? The famous phrase is GOC. God only knows. No one tracks how much of this material is recycled. We did our last survey was 10 years ago, or in 2004, and we estimated 140 million tons of concrete done, but that was like how long ago? 28 million tons of mixed C&D. Waste Business Journal said there were 40.2 million tons of mixed C&D done in 2008, but they haven't done an estimate. No one else has, and asphalt's probably 150 million tons. These numbers have all been gone up in recent years. We have a new white paper coming out that will look at it more closely. Should be out should be out, and you can see it on our website www.cdrecycling.org. How is it recycled is a good question because, it just doesn't go into a black box and come out with beautiful end products at the end. This happens to be a simple little plant down in South Florida. That's why they're able to operate outside like this, where right now you can see the excavator feeding a primary screen, which takes out 6 to 8 inch minus material. You can see the bigger material going straight up to a picking line, and you can see that the 6 to 8 inch smaller material is taking a left turn there out of the screen and then going up on the left side to a second picking station. This is how our primary screening begins for sorting of this material. Once it gets up on the top of these sorting lines, we use humans to do most of the immediate sorting. The reason for that is we can teach them to pick out whatever special item needs to be done that day. Usually we're always picking the wood and the metals and all that, of course. But if there's a market going on for something special, then we can tell those workers right then and there, that's what I want you to pick out today. The amount of material they can handle per day is also increased by the number of employees used. Obviously, costs go up. We also use mechanized systems. This happens to be an air classification system that separates the lights from the heavies. Usually you're separating out your plastics and stuff, or even your wood from your aggregate, being the brick, the concrete, and the asphalt. This mechanized means works pretty well, but we need to still have humans on the line. By the way, this facility happens to be in Chicago. The markets that we're going to talk about a little bit, well, here's the main markets that we have, and the markets we're going to talk about are the first 4 up there because they're the big ones. But just in general, for the last 3, everyone picks metals. It's just where the money is. Everyone picks old corrugated cardboard. There's usually a good market for that. Plastics remains a very difficult market for us, really difficult market. And we would hope that someday that we'd be able to grow it, but it's just there's too many barriers to it at this time. Concrete, common, ubiquitous building material, a great one to use. Has a lot of going for it. Most commonly used as a road-based product, some kind of a base, either sub or regular base for roads. By far, most of the material is used for that. You can crush it on site and use it there. You don't need to move it on and off. Other uses include as an unbound fill for erosion control, especially at construction sites. You can use it as aggregate for new asphalt and concrete, but you have a lot of cleaning up to do, but it can be done. And basically, you can use it for any normal aggregate uses. We have a website you can check out, concreterecycling.org. Doesn't that look like a big pile of regular old rock? I mean, but that is recycled concrete. The barriers to its use are constituent questions, the usual stuff that we get. What's in it? Something like, it's really been solved over the years that there's really not much no problems with it. Coal ash was a question, but the EPA came out with a ruling saying that the beneficial reuse of coal ash as a replacement for cement and new concrete was not harmful to human health, and they so that we can continue to recycle it, because you can use coal ash to replace cement, and it's an environmentally friendly action to do. There are economics in some parts of the country where it doesn't work because the cost of natural aggregate is too low, so you have to compete against that. There's also stubbornness. Old Joe at the highway department doesn't want to use this newfangled recycled concrete. However, it has been used for more than 25 years in this country, and it's proven its worth. So that excuse should be gone, and we must be doing something right if we're getting 140 million tons of it annually. I forgot to mention, by weight, this is the most recycled material in the country. Asphalt says it does 150, but we're not sure it gets that high. Drywall. Very difficult material to find an end market for in most parts of the country. Not easy to process either. The most common use is land application. It's a beneficial use because it will affect the pH value of the land, but because it's so cheap, it's a very regional market, because out of the ground it's $2 a ton, and you can imagine with our processing costs and all that, we're more expensive than that. You can also use it as compost. It works real well in there as an addition. New wallboard, but that's not too commonly done for a bunch of reasons, but mostly it has to do with cost. Portland cement, when you get at the end of a cement kiln, clinker comes out, which is the end product of a cement kiln. It is then ground down to a powder, and you need to add some kind of gypsum product to the cement. This recycled drywall works really well. Works also as an animal bedding, and of course you can bring a little grinder on site to a project, grind there, and leave the material on site there, saving on trucking cost and also environmental benefits. We have a website, drywallrecycling.org. The barriers are just economics. Flue gas desulfurization, FGD, was a byproduct of coal-fired power plants, and it's quite common from their scrubbers, and it's quite common throughout much of the country. So FGD drywall is dirt cheap to use, and we can't really compete against it. There's a lot of drywall out there, very plentiful. Regulators don't really want to support us. They're a little worried about the contaminants on post-consumer drywall, so mostly you're only going to see construction waste recycled anyway. But then the regulators make it very difficult to land apply it at any great volume, so it has a slow market going there. Like I mentioned, there can be contaminants in there, especially in the older drywall. It's just a difficult material to recycle. You run it through a grinder, and you're going to see more dust than you can imagine, and it'll blow around. So you have to either keep it inside or be out in the middle of nowhere. Asphalt shingles are can be a very lucrative and environmentally friendly practice to go forward. It's mostly used for hot mix asphalt. The same black bitumen that holds together that asphalt shingle is also the same bitumen that is used as the binding agent in asphalt. So it's a natural extension to it. Plus it has on it the shingle has on it a small cubical rock that works well in asphalt. More than 90% of the recycled shingles in this country go into hot mix asphalt. Cold patch is another small product that's made from it. Dust control on rural roads is where you grind up the shingles to about, I don't know, half 1 inch or something like that, and put it down on gravel roads and run over it a few times, and it'll stay in place. It keeps the dust down. You can use it for temp roads, driveways. It has been used with aggregate in a road-based product. It has been used in new shingles, but not too often. That's only manufacturer's waste. And it has mostly in Europe, but it's just starting here as a fuel product. They have used it as in cement kilns. One thing to point out at this time is there's really two types of shingles. Manufacturer's waste coming straight out of the factory that was rejects because they didn't make quality or something like that, and also tear-offs coming off of people's roofs. That they're two different kinds of material and need to be handled two different ways. We do have a website on this one, shinglerecycling.org, and that pile there is black gold. The barriers remain questions on contaminant. At one time, less than 1% of all the shingles ever manufactured, up to about 1975, contained asbestos, and they contained it at levels of less than 1%, which is below EPA guidelines. So there are some shingles out there. By now, those shingles have recycled through the system. I mean, people replace their roofs every 20 years, and these were last made in 1975 or so. So it's been these shingles are pretty much out of the system. You might see them occasionally, and when somebody's got 3 layers on a house, and most of our recyclers know that's a load just to reject, don't even bother. Although most states do require testing for incoming loads of shingles for asbestos. Also, petroaromatic hydrocarbons, which is a common with anything to do with bitumen and asphalt, you can get a little bit of runoff on that. But if it was really a problem, then every backyard in the United States would be a hazardous waste site because of all the shingles on all of our roofs. So it's really not that big of a problem. But however, never give let a regulator pass up a chance to go for try to protect us. So we have a lot of testing required on incoming loads, and sometimes make it economically unfeasible to test all these to test every load coming in, and then you got to test afterward and all that, and just makes it economically unfeasible. But most states have backed off a lot on that, realizing that when you have we have a member who has 119,000 test of incoming shingles and like 17 or fewer than 17 hits, and usually you can tell, unless all those were less than 1% within EPA guidelines, you can usually tell when a load comes in, take one look at it and say, no, that's no good, and get it out of here. You can tell. It's also a very difficult material to process. It's very abrasive. It beats the heck out of a grinder. But fortunately, economics can be very favorable because you are replacing oil. Right now, it's been as high for the bitumen as much as $800 a ton, and right now it's over $600 a ton. I don't see it coming down anytime soon. C&D wood. By weight, most mixed C&D plants, like this one here, get about 40% of what they take in is wood. The most important product to find an end market for when you're starting a mixed C&D recycling plant is the wood. What are you going to do with it? The most common use for recycled wood is fuel, some kind of a wood fuel product. Man has been using wood since the beginning as a fuel for fire since the beginning of time. We did a life cycle analysis to see if it was worth doing environmentally friendly to continue to use the material as a fuel product. And even with the transportation and all that, it makes sense because if you think about it, we are replacing with this wood fuel, which was we are replacing either gas or coal. And if those had stayed in the ground, their greenhouse gases would have stayed in the ground with them. But because the fuel wood, whether it be in a landfill or in a forest or wherever it's going to fall, we're still going to release its GHGs. So one way or another, we are recovering the BTU value of this wood. It makes not only economic sense, but environmental sense to use this as a wood fuel product. However, we would like to do more added value products because the recycler makes more money at that as well. Mulch is a slightly higher value added product. That's probably easily the second most common product. It makes a great mulch because unlike natural wood, this is already kiln dried wood. It lasts longer than natural wood. Compost and animal bedding is a no-brainer. We very commonly do that. In fact, with the compost and animal bedding, you can add in a little bit of recycled drywall. Medium density fiberboard and OSB board, Those OS board, they are very added value products, but you have to have super duper clean material, and there's very few outlets that take it. Now, we'd love to see more of that, but it's just not a lot of opportunity. But remember, there's a lot of wood out there. There's a fuel product right there. What are the barriers to use? Probably the biggest one is the lack of the value-added outlets. I mean, you know, there's only way we can do anything is with the wood right now. It's very regional. Stuff's heavy. You can't move it too far. Right now in Illinois, in northern Illinois, most of the wood fuel is going up to Wisconsin. There really isn't any good outlets around here, the type of boilers that would take it. So you've got to find the market for this before you can really make a successful C&D recycling operation. Regulations and legislation also can stymie this. There's a lot of pushback against using this as a fuel product, but frankly, your options are this. For most of the C&D wood that we get in, your two options are we can recover the BTU value through fuel, or we can put it in a landfill. Which one you like better? There are contaminants that have to be removed from it. The most common ones are CCA wood, decking material, and that kind of stuff. The A stands for arsenic, copper, chromium, arsenic. You want to get that out of there. Lead from paint, because as you might remember, lead-based paint was made until the 70s as well. And we have 1979, I believe, and you have to remove as much as that as possible, painted stuff. But you know, the greenhouse gases I remarked on earlier. The problem is more emissions than anything. You know, the pushback we get is, well, you're trying to put all this poison. No, no. The fuel doesn't matter. It's the stack emissions that matter. What controls are on the stack? So if you can control your emissions, you can use anything for a fuel. But we do keep our wood fuel very clean, removing all the CCA and lead-based paint wood, and in order to comply with all rules. The non-hazardous secondary materials rule, NHSM, was going to seriously affect the use of C&D wood fuel. However, after explaining carefully the science to the U.S. EPA, their rule writers decided to exempt C&D biomass from that very onerous and strict non-hazardous secondary materials rule, because we were able to show them that yes, it is a safe material to use as a fuel product, and convincing them is not an easy task. So I hope this helped you, give you a little bit of the basics. If there's anything we can do, here's my contact info, but more importantly, go to www.cdrecycling.org, and there's probably more information there. Thanks for your time.